Hi, everyone. Thanks very much for having me. It's exciting to be a part of the conference. My name is Pete Goddard. I'm the CEO of Deephaven Data Labs, and I'm going to take you through a tour of some of the things you can do with the open source projects that and products that Deephaven makes available. Deephaven is a data software company that makes products built for handling real-time data in very compelling ways, both on its own as well as in conjunction with static data. Let's drop my face and kind of hop right into it. I'm gonna fix this. So Deephaven's built, as I suggested, from the ground up with real-time data in mind. It's built to make both the individuals very, like you, very productive with a good number of use cases, including analysis, data development, but in particular, data science, AI, machine learning, all in real time and at scale. At the core of the value proposition is something we call streaming tables. Streaming tables are a very simple but powerful concept where we marry some of the great attributes of event streams with some of the intuition and natural capabilities that you're familiar with of tables. So think of data frames here. So in Deephaven's case, we're doing a lot of work to ensure that the tables that you operate on can work in real time. They can change underneath you in a variety of ways, appending, modifying, shifting in various ways, and you can just operate on them with familiar patterns. There's a lot of engineering in the background to make all of this go. In particular, fundamental to the way that you'll interact with the system is our value, or the way that we're handling incremental updates. We're handling deltas of data instead of simply data itself. And this allows for a lot less data to move between nodes or across the network, and allows for much quicker updates because you're doing smaller calculations, particularly when you think of large tables with a lot of data streaming in real time. We're able to operate only on those incremental on those incremental changes instead of the full batch data. There's a lot of infrastructure and code that supports this idea at the API, as well as the data engine layer, as well as pipe through to the user experiences. And I think it's some of these user experiences that I'll be demoing now. So let's hop right into it. I'm going to open a command line here. And I'm just gonna bring up a Deephaven engine, right? So if I essentially am going to following the methods, if I go to our website and then I just go to our doc site and you just go to get started, you'll see that there's instructions here about how to launch a Docker container with Deephaven. This is one of the two popular patterns that I'll show here, the second being using Deephaven as a Python library. So now my container, my Docker image has launched a Deephaven server. I can go to any browser. In this case, I'm going to get this out of the way. I'm going to launch an incognito window here, just so I have nothing cached or anything like this. And I'm simply going to go to localhost port 10,000. And you'll see that there's now a Deephaven IDE. I'll show you other experiences in a moment, but this is a web IDE that you can launch either in Python. We're very much a Python first experience for working with data, or in Java-based languages. You can launch a similar experience here. And this is just an interactive and exploratory experience to work with data. I'm going to, rather than watch me type, which wouldn't be a very efficient use of your time, we're going to go to the File Explorer and we're going to pull up a notebook that I've seeded for this demonstration. So the first thing we want to do is we want to work with some real-time data. We just want to get it some sort of real-time source connected to this Deephaven server, which is then feeding this Deephaven JavaScript client that we can see. So to do that, we've made available a Kafka feed of some crypto data. And all we have on the screen here in the notebook is a configuration, that allows, essentially this is a connection configuration in this dictionary here at the top. We use that to connect to a Kafka topic that's publishing crypto trades from, from one of the exchanges. The schema for the data is automatically retrieved from the schema registry. So the Deephaven table automatically has the right column names and data types, as you can see down here. And one thing we do in configuring this is we make a choice about whether we want this to simply be a table that grows, meaning as new events come in, they're going to be appended, or one that will simply stream. So you'll get one shot at the data, and oftentimes this is a good way to support aggregations without consuming memory if you have a lot of data moving through and you expect it to grow for a very long time. Or we have something in the middle that allows you to essentially have an appending table, but you can bound how many records you're going to keep as that data comes in. So let's just run this. Let's just connect to this Kafka stream, and then we create this table called Crypto Live here. And you can see that everything in Deephaven is a table, whether it is static or it is changing in real time. It'll be a table, and you'll see quite soon that you can use the same methods regardless, right? So, so this is a table of new data coming in. There's 6,511 records, and now there's 7,882. If I flip it on its head, you'll see it more readily. That not only have I connected and received a snapshot of data, but I'm getting new event streams from that redpandas feed, that Kafka feed or Kafka compliant feed that I connected to, right? And there's lots of capabilities here just from the UI. Oh, I want to filter. Oh, I want to create, I want to create a custom column of sorts of, this is, I don't know, price times size, right? All right, so now that's being calculated, and sure enough, if I take this filter off, it is being calculated in the background for everything, and everything is updating in real time. There's other things you can do directly with this table API, but this is, I know you want to see the demonstration of code rather than user experiences, but know that exploring data is really pretty valuable from these table widgets and other widgets that you'll see in a moment. Okay, so all I've done is just gotten real-time data. Okay, and now one thing that I want to demonstrate very quickly is that Deephaven can work with real-time data and historical data in much the same fashion, using the same syntax, using the same methods. It can be joined, it can be merged. So we're just going to hop through that really quickly. I'm going to I'm going to essentially write this table or a snapshot of this table to Parquet really quickly, okay? And now you see, just one moment. Okay, so now that's been written to Parquet, we should see that if we go to our Finder, sure enough, there's now this Parquet file, Crypto Live Parquet that we just wrote, okay? For fun, we're gonna now read in that Parquet file. Okay, so now we have both the live that is growing as we know, and then this one that's 29,000 that is not growing, right? This is the static data. So we have two sources. One is live and updating, one is static and batch if you'd like. And now we want to show we can use the same methods on both. So here we'll just do something very basic with the live data. We're seeing the last 10 rows and calculating a new column programmatically. And now all I'm going to do is I'm going to manually go in, instead of going basic live, I'm going to go basic static. and I'm going to refer to the table crypto hist instead, which is the static one. And now I'm using the exact same methods, with the live table as the static table, right? Just a very simple example of being able to do that, right? And you can see one of the core concepts of Deephaven is not only this concept that a table can stream or it can be static, but also that that data flows through an acyclic graph, right? So I have crypto live up top and the basic live down bottom. This is a table that we do some stuff to, and then that creates a dependent table. And sure enough, they both will be ticking in real time. One will be feeding the other, and obviously this can be a complicated graph, not just the simple one that I've set up, but basic. This allows for DAGs to be developed both within process and across the wire. As you become more sophisticated and you're able to do handle these use cases, really just programming or scripting in a very linear fashion. Clearly, you can do much more sophisticated things than just these basic operations, but we'll get a taste of that in just a bit. We want to show, not only can we use the same syntax on static and dynamic data, but we can merge both of them, and we can also join them, right? So I want, there's no concept of windowing or any requirement there. You just work with tables. Those tables may be, if we go to Bitcoin US, that's going to tick more, I think. If you work with tables, those tables may be static, they may be streaming, they may be changing in any variety of ways. You as a user don't have to worry about that type of stuff. I want to hop through a few more operations. Quick little time check. So let's take this data, let's sort it, and let's split it into two other tables, one that's just Bitcoin and the other that's just Ethereum, right? So now, right, simple operations. If you've written pandas before, which I'm sure many of you are familiar with, or if you've worked with SQL, many of the concepts will be very, very straightforward. There's nice autocomplete and nice support for these table libraries, and you can see, all of these tables, will be updating, as new data is coming in. So we've demonstrated a filter. Now I want to demonstrate bringing these two tables together. So I have, arguably BTC Ethereum, this one that took all of them and just looked at a couple of the crypto pairs. Let's say that's on the left, and on the right, I'm going to have both Bitcoin and the Ethereum, right? So all of these are ticking in real time, if you like. Sorry, I think I flipped that one. So as new data is coming in, everything is going to be ticking. And now I want to join the table on the left with the two on the right. So I'm just going to take the timestamp from the table on the left and then say, what was Bitcoin and Ethereum at the time either one of them traded? So I'm going to do an as of join, which is a time series join that's driven, by the key of timestamp. And then from the right table, I'm going to bring some columns over and I'm going to rename them. And then after I have that work product, I'm going to just do a simple calculation. Right, and now we can see that all of that, that join is going to produce, it's going to bring over that data as I suggested. It's all going to update in real time, and that ratio is going to be calculated in real time as well. So we've seen a time series join. Earlier I showed you a relational join, and let's say we're just going to take this data and we're quickly going to calculate an EMA, where you can essentially do a grouping Here in this case, we're grouping by a 0 key because, and then we're just calculating any EMA as new data is coming in. Very, very straightforward syntax to do that. You can obviously you support EMAs either with based on time or based on ticks. And then from there, we want to programmatically, you could certainly plot from the UI, but we're going to programmatically plot here. And in this case, we need to do some typecasting. Deephaven supports infinite precision calculations. In this case, the original data from the crypto data was brought in as big decimal. So we've just simply done some conversions into regular floating point numbers for efficiency before plotting them. And this is a real-time plot. So you can see that some data is ticking in here at the right. If I turn these two things off, the plot probably looks a little bit prettier. And now you see that EMA calculating as well. It's all very interactive. You can certainly support plotting millions of data points, even though there's thousands of pixels, because we've done quite a bit of work to do smart downsampling and support all these, pixel perfect, minimum, maximum, and other stuff like that. But we know that you also, you'll want to use our table or our plotting API, which is really just integrated with a Plotly backend, but you'll want to use other Python visualizations as well. So when I launched this Docker image, it was loaded, as supported on our doc site. It was loaded with with matplotlib, and there's all sorts of infrastructure to support sort of custom plugins that you make available. So in this case, what we're going to do is, instead of only relying on only showing real-time plotting with our Plotly integration and our plotting API, I'm going to show a basic manipulation where we use that matplotlib and we create a sine wave in real time that then also updates. So we think this is kind of a big deal, where certainly you can snapshot any table data and plot it in matplotlib or Seaborn or ggplot, as well as obviously in our plotting infrastructure. But it's pretty compelling to be able to use those tools, and as a table updates, be able to plot things dynamically in updating fashion with those very, very popular libraries. So what I've tried to accomplish here is to give you a basic tour of some of the capabilities of this web IDE, where you can interrogate data, from the command line, or you can use notebooks and work with widgets, both tables and plotting widgets, that allow you to really explore and interrogate data in compelling fashion. It's beyond the scope of this demo, but certainly it's the case that you can use this infrastructure to launch applications, headless applications to support dashboards and there's pretty easy to use infrastructure and how-tos to support those types of use cases. Certainly our community users and our customers certainly rely on this for interrogation and exploration, but also very much to support all sorts of automated applications. Before I run out of time, though, I would like to show you what it's like to work with Deephaven and Jupyter. That's it. Okay, so here I'm going to Jupyter Notebook. This is just a standard Jupyter Notebook. The first thing I'm going to do is I'm going to connect to, or I'm not going to connect, I'm going to launch a Deephaven server. So from your Python experiences, you can simply launch Deephaven. And we should see in a moment that everything is connected. I just showed you what it might be like. You can certainly add different arguments to that server launch if you want to configure it. It's in various ways. In this case, we just used a generic, the default configuration. And now you can see I have a server that I've started. Again, this is not the one that was launched from the Docker image that I previously showed you. This is a new instance that's being launched from, from here in Jupyter, from essentially that you could do so from the command line. The first thing I want to do is we're going to write some real-time data of a different nature. So in this example, instead of working from a Kafka feed of crypto prices that I had available to me, I'm going to work with Twitter data made available via their API. So I'm going to connect to their API in just a moment, but I need to be able to write that data in real time to Deephaven. We have a method called dynamic table writer that's very generic and very powerful that allows you to write data from a, sort of in any fashion. So it's essentially a method that allows for pushing data into Deephaven, from any type of source you can contemplate, or from a great variety of sources. It's very, very configurable. So in this case, all I'm doing is I'm sort of defining the table. Is okay, what are the different columns going to be called, and what data types do they have? Okay, now I've defined that table. Now we're gonna gloss over this a bit, but I'm gonna go to the Twitter API. I'm gonna use my token, which I should probably get off the screen. And then I'm gonna get tweets as they're made available in real time, right? Straight Python. Certainly all of you, most of you, I assume, have great experience with Python. This is a standard, this is the type of API integration that are probably quite accustomed, quite normal for all of you to write. And the last thing I'm going to do is turn it into a Deephaven table. Right, so now I've connected to that, and but I want to make evidence of that. So here in Deephaven, certainly already I've connected to Twitter, my Deephaven server, which is running, in local resources or virtual resources here on my machine, is now getting data from Twitter, but I want to see it. So one thing we've done is we've made all of those Deephaven widgets that I showed you before, both the dynamic tables and interactive experiences, but as well as those plots available to Jupyter. So sure enough, we see here the Twitter feed coming in, right? So all I did is standard API connection, and now I'm receiving this table data, and all of this is, the same type of experiences, interactive that I was showing before. All of this is, filterable, and you can use some of these overflow methods that we were talking about before directly on this table data. And again, the thing that I want to make sure comes through is you're working with tables. They happen to be dynamic, but you're insulated from all of that. And then, let's say we want to run a basic table operation on this that just says, okay, I want to take this table called tweet table that I just created, and I want to do something with it. In this case, I'm going to, I have some keywords that I identified above that I think people are tweeting about, and I just want to run an aggregation of, how many tweets have those keywords in them. And now you can see that, let's see, which way is it? Yep, you can see that this tells you, how many of them have news, monkeypox, COVID, cats, or dogs in their tweets as they're coming in. And sure enough, you'll see that this is updating every 5 seconds. Essentially, we have, that's the frequency at which we're querying the Twitter API. So I want to be respectful of time. I want to provide a few minutes here at the end for Q&A, but hopefully you're able to see that working with Deephaven really empowers you to use your, use table methods identically on static and dynamic data, and to empower your use cases, whether it be interrogation and exploration, or application development, or sophisticated signal processing. I've elected not to show you, some of the sophisticated use cases where you use third-party libraries, Python libraries or user-defined functions, you know, within column updates, or you know, as you know, or other aspects of the use case. But certainly, it is the case that our customers and our users, our community users, our open source users rely on Deephaven sort of for the whole gamut of their use cases, from analysis all the way through AI. And with that, I'm going to take a breath and see if any questions have come in that these. So yes, so Prajesh asked a question here about, do these plugins have an input parameter for refresh frequency? That is something that you can configure for the system. Yes. So essentially, it is though Deephaven is designed for incremental updates as they arrive, it makes sense to micro batch the arrival just for efficiency perspective, so that you're not grabbing every single update if that's ineffective for your use case. So that is something that you can configure, yes, and you can configure it both, you know, sort of at the ingestion layer as well as at the UI layer, because there may be reason the UIs are essentially a coordinated collaboration between the Deephaven server and a web UI, and so it's nice to have a degree of freedom there in regards to those update rates as well. Are there any other questions? Okay, well, with that, I can't thank you all enough for your time, and it's been a real pleasure to be a part of the conference, both speaking with all of you ad hoc in the virtual hallways, as well as seeing other people's content, and then being a part of it here as a presenter. I hope you bear Deephaven's open source projects in mind as you pursue your use cases. We have a pretty compelling engine for working with real-time data. The concepts of that have been strung through to an API called Barrage, which is an extension of Aeroflight, which is itself relies on gRPC. So we think that that is fundamental. Transport, which really is enabling our concepts about streaming tables and updating tables, and in our engine, incremental updates. And then we have other things here. Certainly, we make available, for example, that web client that I was showing you, which is well integrated with our API and our engine, but it's certainly available as a really just slick grid if you want to use it in that fashion with, for example, some other engine. Thank you very much for your time.